Hi there. In today's lesson, we're going to be learning about derivatives of a polynomial function, and this is Unit 2, Section 2. So 2.2, derivatives of a polynomial function. So before we start, we should know what a polynomial is. So let's recall that a polynomial is defined as It's defined as an expression with two or more algebraic terms. And this can include variables. And remember that algebraic terms are separated by addition or subtraction, but not multiplication or division. Okay, so this is just a general expression for a polynomial function. So f of x is equal to a subscript n, x to the n, plus a n to the minus 1, or subscript n to the minus 1, and then x to the n to minus 1 plus a subscript n to minus 2, x to the n minus 2. So we get that dot, dot, dot. Now on the other side of things, we're going to go a subscript 2, x to the 2, and then we're going to do plus a times x. And this is so that, or if a is equal to the, is all real numbers. Okay. So today we're going to be learning about the 5 derivative rules so far. There are more. There are 2 others that will be, or 3 others that we'll be learning about later. But today we're going to be specifying the 5. So let's write down 5 derivative rules. Okay, so the first rule we'll start off with is called the constant function rule. And the constant function rule is defined as, so if a function, f of x, is equal to k, and k is a constant, then their derivative, so f prime of x, will be equal to 0. And let's remember to specify that k is a constant, so let's just do a little star up here. K is a constant. So now let's write it in Leibniz notation. So write it, let's do this. So it's equal d by dx of k is equal to 0. Okay, so let's have an example of this. Example. So let's do, say f of x is equal to 3, and example one, do this example one. If f of x is equal to 3, find f prime of x. Okay, so we know that, as the constant function rule states, if a function equals a constant, the derivative is just 0. So f prime of x is equal to 0. So this rule is pretty straightforward. So now let's move on to the power rule. This is a really important rule for polynomial functions, and it's really helpful to when you're finding derivatives. It's so much faster than doing finding the limit and that long way. So the power rule. So the power rule is defined as, so if a function, if f of x is equal to a variable to the power of n, in this case, and n must be a real number, then the derivative, so f prime of x, is equal to n times x to the n minus 1. And let's remember that n is a real number. So now let's write it in Leibniz notation. So d by dx of x to the n is equal to n times x to the n minus 1. So let's do an example of this. So example 2. So f of x is equal to x to the 8. Okay, and then we want to find f prime of x, so the derivative. So by following this formula, we can see that we pull n out in front. So let's start by writing f prime of x is equal to. So then we go pull 8 in front. So that's the n. 8 is n in this case. And then we do times x, and then to the n minus 1. So 8 minus 1, 7. And there's your derivative. So another straightforward rule. Now let's go to the constant multiple rule, our third rule, the constant multiple rule. So let's define this. So if f of x, so if a function is equal to a constant k times a function, so g of x, we'll say, then the derivative, so f prime of x, is going to be equal to the constant times the derivative of the function, which is g prime of x in this case. So let's do Leibniz notation. Which is d by dx is equal to k times y, and y would be the other function representing g of x. And then equals k, so we bring that in front, and then dy by dx. So this is kind of confusing right now, but an example will help us out for sure. So let's do example number 3. So let's say f of x is equal to, let's do 9 times x to the 3. So as you can tell, this looks very similar to the derivative when you use the power rule. So let's just start off by using so see the 9 is a constant. So right now, we'll do f prime of x. We're going to take 9 and put it out in front. So we'll have 9 here. And then I like to use brackets, so we really know that 9 is kind of out. And we're not finding the derivative of 9, we're finding the derivative of this, x to the 3. Okay, so x to the 3. So now we're just using, if we take out the 9, now we're just using the power rule. So bring the 3 out in front, multiplied by x, and then 3 minus 1 is 2. Now we need one more step to just expand. So 9 times 3, it's 27, times x to the 2. And that's your answer. I find it's easier sometimes to use Leibniz notation. So let's do that Leibniz notation now. So d by dx is equal to 9x 3. So you bring the 9 all the way in front, and then you do d by dx of x to the 3. So here you can really see that 9 is out of the question kind of thing, and we're just finding the derivative of x to the 3, which is 9, and then again we have 3x to the 2, and that's equal to 27x to the 2, which is the same answer as before. All right, so next we're going to do the sum rule. So the sum rule is defined by, so if a function is equal to a function plus another function, so p of x plus q of x, then the derivative, so f prime of x, is going to be equal to p prime of x, so the derivative of p of x, plus the derivative of q of x. So in Leibniz notation, we have that d by dx of f of x is equal to d by dx of p of x plus dx, d by d of x of q of x. So we'll do these examples later when we'll blend all of these rules together. So now we'll move on to the difference rule, which is the exact same as the sum rule, except it's obviously subtraction. So let's get a new